Hi guys, today I'm going to talk about units, elements, compounds, and chemical equations. I'm just going to go through all of them very briefly and generally because it's very basic. So I'm going to start with units. Units are basically what are units? Units is any standard used for making comparisons in measurements. So we use units for measurements. We need to know how to use anything we're measuring, how to call them, um, how to represent them basically. So the concept of SI units, SI is shortened form of System International. It's just a metric system. It's just a modern form of metric system, which is representing the um, basic units. Which is accepted everywhere in the world, so it's used everywhere. Um, okay, sorry. Here in System International, um, so we have SI base units, System International base units, which are like, for example, for length is meter, for mass is kilogram, for time is second, it's not hours, for temperature is Kelvin. You should definitely know what are the SI symbols because every calculations in physics or chemistry you're doing, you should use SI units, or you should know how to convert them to each other, like second to hours or gram to kilogram, okay? In the second hand, we have SI derived units, which are derived from the SI base units, okay? For example, in case of frequency, which is a very important quantity, we are using hertz as a unit. How do we produce hertz? We produce it from second, which is a SI unit, and we make it by 1 over a second, and we make up the hertz. And you can see how all other stuff like force, pressure, energy, power, electrical change are produced and derived from the SI base units. Okay, and in the second, in this right side, we have SI. sorry, SI prefixes, and these are also very important. You should memorize them. How are the symbols? How do we call them? And how is the factor? Like 10 in power of 12 is tetra, or what is giga, what is mega, what is kilo, what is hecto. And you have to know how to convert these to each other in case of dealing with the equations. Okay, I'm just very fast because I'm short in time. So I'm going to talk about elements, chemical elements. So, in the first hand, we need to know what is the definition of the chemical element. Basically, chemical element is any substance that cannot be decomposed into simpler substances in the by the ordinary chemical processes. Okay? So, and chemical elements is consisting of atoms having identical number of protons in their atomic nuclei. For example, oxygen is the very basic fundamental 20% of the earth of the atmosphere is oxygen is needed for life. What is the symbol? It's O. And some other specificities is defined next to the element, which is really important, and we need to know to define the element. For example, the first one is atomic mass. As you know, atomic mass is the number of nuclei and proton, and in case of O is approximately 16, and the atomic number, which is number of proton, is 8, and other features is seen here. So you can see periodic table. Periodic table is like full every kind of elements you have seen on Earth, and it's seen and is discovered so far. It's represented in periodic table. You will get familiar with this later for sure, but for now we just took out oxygen as the example of elements to show how we represent them. Okay. And the other one is fluorine in here. I showed fluorine. Fluorine is also very important, very important specificities and very interesting. So elements are also the fundamental materials of the chemical compounds. We can see how chemical compounds are made up from elements because the next topic is chemical compounds. In the other hand, we are gonna talk about chemical compounds in here. What is the chemical compound? A chemical compound is a chemical substance composed of many identical molecules, composed of atoms from more than one element held together by chemical bonds. So here we have three examples. The first one, which is very common and it's very familiar to everyone, it's H2O, which is water, and it's composed of hydrogen element and oxygen element. They are making up the H2O compound with the chemical bonds. In the middle, we have methane, which is the simplest organic compound, which is your cooking gas is like it's having methane, and methane is like the simplest and very very important organic compound. And in the right side, we have a little more complex compound. You can see it's also an organic compound. It's like you can see how atoms are held next to each other and held by each other with chemical bonds. Okay, so the next topic is the chemical equations. Chemical equations are um, let me see. A chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formulas. It's just using symbols and formula to represent the symbolic um, in representing the chemical reaction. Okay, so on the left hand, we have reactant, and on the right hand, we have products. As you see, these are called reactant and these are called product. And reactants are yielding products. Okay, so as you can see in the first equation, which is very fundamental and basic, and it's like the simplest equation on earth, it's producing H2O out of hydrogen and oxygen. So, as you can see in the second picture, what is subscripts and the coefficients and how the formula is produced. So, something is very important in case of equations, that is that every element or atom should have the same number in both sides of reactant and product. And you should use subscripts and coefficient to equivalent the number of the atoms in both sides of the equation. For example, in case of the first picture, which is hydrogen, we have 4 hydrogen because 2, which is coefficient, times 2, which is subscript, it's making 4. So we have 4 hydrogen plus 4 hydrogen making up another 4 hydrogen on the left side, on the right side. So basically, we have 4 hydrogen on the reactant and 4 hydrogen on the product. So it has to be the same, as you can see, and it is the same because we use subscript and coefficient to make it like that. It's called stoichiometry as well. So in the other topic, we have types of chemical reactions. I'm going through them very fast. I'm very short in time. Types of chemical reactions are we have five different types of reactions. We have combination, which is also called synthesis. As you can see, the example is C plus O2 making up CO2, a carbon dioxide, which is a compound, out of elements, and um, yeah, making out of C and O2. The second one is decomposition. Decomposition. For decomposition, we have hydrogen peroxide decomposing to O2 and H2O. This is also very important equation. The third one is single displacement. In case of single displacement, we have one atom is adding up to a compound and it's displacing. As you can see, xenon is displacing with Cu as is making up xenon Cl2. And then we have one single copper in the right side. And in double displacement, it's the same concept, but you can see both sides, both of them in the reactant are compounds, and the displacement is happening. The last one is combustion. It's basically the burning concept. The example equation is methane combustion. It's also using it the same. It's the equation is happening in the cooking gas in everyday life. Thank you for listening to my presentation. I hope it has find you. It has helped you. Thank you.